Yeah, so Jared, what are some of the advantages of combining a traditional, maybe fossil fuel-based heating system and a ductless heat pump? And kind of what do we mean by, combining those things?
Yeah, so that's a great question. So when I talk to customers about heat pumps, there's what I call two balance points we talk about, right? The balance point most customers know about with heat pumps, and this is really with the more traditional heat pumps, is a temperature balance point. So basically, considering that heat pumps, the way they work is they move heat from outside and bring it inside. As it gets colder outside, the more traditional, and I'm not talking ductless or mini splits, but the more traditional systems, they start to lose their capacity as it gets colder, and they get to the point where they lose enough capacity that they wouldn't be able to keep up, right? So that's your typical temperature balance point. With mini split heat pumps and heat pumps in general, I like to talk about a different balance point, and I call it the economical balance point. All right. So the idea behind this is, if you have a natural gas system, most of our customers have natural gas, don't complain about their heating costs, right? Um, because it's relatively inexpensive fuel, the systems are relatively efficient, so on and so forth. Oil, propane, much different conversation, right? So take oil for example. Oil, when it's warm out, my heat pump is more cost effective to heat with, right? Because the house needs aren't as high, right? It doesn't need as much heat because it's not so cold outside, and there's still plenty of heat in the air for that system to readily move into the house, right? But as the temperature continues to go down, now the house needs go up. There's less heat available outside, so my system has to work harder. When my system has to work harder, now it starts costing you a little bit more to operate. So what an economical balance point is that temperature where a BTU out of your legacy existing heating system versus a BTU out of my heat pump, which is going to be more cost effective. All right. Now, depending on what your fuel source is, natural gas, it's going to be probably between 40 and 50 degrees. Oil heat, it's going to be between 20 and 30. And propane, it's probably going to be between 0 and 10 degrees. So, depending on what your existing fuel is, we might adjust those switchover temperatures.
So, talk a little bit about, the when it might be beneficial to combine or integrate the two systems, and what are some of the factors involved in that decision?
Well, the big thing would be our customers that have natural gas, right? Because again, we're generally not looking to increase customers' utility costs, right? So, with customers that want to utilize the heat pump technology, but maybe don't necessarily want to, cost them more to heat their home, but they maybe again want to use the heat pump some of the times. That could be a very good option for those customers. For some customers, maybe they've got a newer, more efficient system, and they want to add AC into the house, but they want to utilize the Mass Save program. Doing integrated controls opens up that avenue to them. So there's various different reasons why customers might move this direction. And we work with our customers and consult with them to figure out the best solution possible.
What are some of the challenges or drawbacks, in your opinion, when it comes to integrating a traditional system with a heat pump system?
Well, specifically, we're going to talk about mini splits when I answer this question. The big thing would be integrating those in isn't exactly easy, right? Your traditional HVAC systems, whether it be wet heat, more traditional, conventional forced air heat, they all work on 24-volt controls, right? Your thermostat, that's a 24-volt control. But in all reality, if you think about your thermostat, it's a glorified light switch, right? It's turning your heating on, it's turning your cooling on, but it's just doing those things at temperatures, right? Where my mini split systems, the way they operate, they're all communicating. So the indoor unit's talking to the outdoor unit, the thermostat's talking to the indoor unit, which is also talking to the outdoor unit, and they're all passing information back and forth. So it's not like I can just slap on a regular 24-volt thermostat and make that power up existing heating zone. So we have to add these separate device auxiliary relay kits and things of that nature. Um, we most likely have to change their thermostat to either a brand specific thermostat or a dual fuel thermostat. So, it certainly has its challenges with the extra material and labor needed to do it. And sometimes, even though there's incentives to go that route, sometimes that added cost can basically wipe out that rebate amount. So, again, we'll work with our customers, consult with them to figure out what best fits their needs.
Can you talk a little bit about maintenance and upkeep requirements for systems, especially when you're talking about potentially continuing to have your old fossil fuel system, and now you're also adding in this heat pump ductless system. Does that just make your maintenance and upkeep requirements and costs that much more because now you have two systems that you have to take care of?
Yeah, it could potentially make your maintenance costs higher. That said, this being New England, Cape Cod specifically, there's plenty of people that have baseboard heat and then a ducted system for their AC. So they already are used to having two different systems that they need to maintenance. So I certainly wouldn't, make your decision purely based on the maintenance cost in the future. But that said, they maintenance just like any other mini split or heat pump system would maintenance. So just having us out once a year, cleaning indoor coil, cleaning outdoor coil, drain pan tablets, checking drain, blowing out drain, checking operation, getting our delta T's, all that. So again, not much different.